This session we are going to see about the practical implementation of a neural network in IR model. As a basic concept, this neural network in IR refers to an application of an artificial neural networks to the task of retrieving relevant information from a large data set. So neural network learns to understand the semantic relationship between the queries and the documents. So the most benefits of a neural network model is semantic understanding. So neural networks can better understand the meaning of words and phrases from a complex queries, leading to more accurate relevancy judgments. Handling complex language is the second benefit of a neural network model, where the model can handle natural language queries with nuances and ambiguities. And the third benefits of applying this model is the adaptability. The model can be continuously improved by training on new data, allowing for better performance over time. With these benefits, we can able to compare standard bag of words representations to a neural network model. So a standard representations, bag of words representation, we have a set of vocabularies, and to this vocabulary, how far the document related to these vocabularies have been represented in the form of zeros and ones. So this is a basic representation. So in this basic representation, we cannot able to find the context, the semantic information has been unaware. If the document is, if the word is there, it is going to be 1. If not, 0. We couldn't able to find the other set of information like this meaning or in context, the word that has been appeared. So this can able to be overcome by a neural network model. As an example representation, we have been given for two words. A have been represented in the three-dimensional perspective and neural in the three-dimensional perspective. So when a document corpus has been there, for those document corpus to this specific set of representation, the word representation, we are just going to identify the document to this particular set of vocabulary and assigning weights to each and every document. So we have a document representation in terms of it, whatever feature we are going to use it, we are just going to adapt it as a dimension specifications over to the documents. So we are just representing it. So this is the basic form where we are going to look it out. So user going to be identified with the queries given. So query terms has been mapped to KB, KC. Using the query words, these query words will be identified to the document terms. So in which the document terms has its own weights. Further, the documents has also asserted with weightage to the terms that it comprises to be. So documents weightage, due to this document weightage, we are just going to retrieve back the information. So we are just going to have the comparison between the query term as well as the document. How far it is going to be similar. If it is going to be more similar, then we are going to retrieve it to the end results. So this is the basic concept of your neural network. Now we are going to see about how neural network model can able to be coded up in Python. So as a prerequisite, we are supposed to incorporate all the libraries to the code. So NumPy for handling the array operations and OS for handling the files, and term frequency, inverse document frequency vectorizer model to be deployed to the code from sklearn.featureextraction.txt, and the similarity, the cosine similarity metric has been evolved, taken up from the sklearn.matrix.pairwise. So initially we are just going to define the sigmoid function as well as sigmoid derivative function. So this is important function as a neural network concept. It is going to be defined as an activation function in a neural model. Okay, so for your forward bias, we'll be making use of the sigmoid function, and for your backward bias, we are backward propagation, we are going to take up with a sigmoid derivative. So we are defining the sigmoid as well as sigmoid derivative previously, and taking up of these data source. So this is my path where the data files exist, and initializing the documents as well as the document names previously as an array or a list. Okay. So we are going to take all those files and going to process it further. So we're just going to check in the folder path in the peculiar folder whether any of the file name that ends with .txt. If in such a case, we're just going to add up to the file path, meaning that we're just going to open the file path in a read mode. That is, this file path is going to have the text file to be opened up in the read mode, and for reading up of a text file in a particular standard, we are going to make use of the encoding UTF-8 format. So we are just going to read it as a file, and the content will be read in terms of a read method. And we are going to append all this information to the documents. And the document name is also being updated in terms of the file name. Now we are going to process it. As the initial state, we're just going to have the document list, taking one by one the document. We are just going to have an initialization for the model. The model has been initialized as TF-IDF vectorizer model. Okay, so this vectorizer, we are just going to use it for the corpus, document corpus. So the model, the TF-IDF vectorizer model, has been mapped to the peculiar model, to this peculiar model, and transform it. All those documents which has been exist, the representation which has been exist, that has been mapped to the model which have been used. So we are just going to save it as an X. And here we are going to have a seed, random seed of 42, which means that for every iteration, when you're going to have every epochs or every iterations when you're going to do it, the value will be changed continuously. Random values will be changed continuously. So in order to avoid that, we are going to fix it as 42. 42 in the sense that I fix it say, number where we are going to adopt it for the variables. And initializing the neural network parameters. So the input neural network input layer has been initialized to the X shape of 1, the number of features which we have been used. And the second initialization is your hidden layer neurons. We have been adopted 5 neurons as an hidden layer and 1 output layer. This has been initialized. So this is our model, neural model. For this neural model, we are supposed to adopt weights to it. So weights you can able to be adopted for the input to the hidden and hidden to the output. So two weights have to be adopted. Similarly, two bias function have to be adopted in terms of hidden, in terms of output. We're supposed to be adopt the weights as well as the bias. So we are just going to have the random values to be assigned to the input layer neurons and to the hidden layer neurons. Similarly, the random weights will be assigned for the size of your hidden layer neurons to the output layer neurons. Weights has been initialized as an random values, and bias values is also been randomly assigned it to the hidden as well as the output layer. Now we are just going to have the parameters to be initialized. So the parameters used is one is the learning rate. So learning rate can able to improve your model performance. So learning rate 0.5 and epochs, how many iterations you are going to perform. So here we are going to mention it as 10,000 epochs. And for this, we have a simulated labels for demonstration, which means that previously when we have a set of neurons to be adopted, we have a predefined label to it so that we can able to have the model performance to be checked with the actual value. So here we don't have any actual values, we don't have any labels to be assigned to the document. So we are randomly generating the labels and mapping it to the documents. So here, so y is going to be the target one, and this NP where we are just going to have the numpy operations where randomly generated values of 0 to 1 for each and every document to be classified either 0 or 1. So we are randomly choosing either 0 or 1 to be adopted for the values, and this is going to be y. So this will be taken up for the iterations. So now going on to processing your neural network model, you are going to start with the epochs, the number of iterations over to the model. Initially, we are supposed to have the forward propagation. So your forward propagation comprises of computation of your weights along with your input, plus you are supposed to have your bias to be added up. Okay, you're just going to have a dot product with your weights along with your input features, the document value, term which have been used, along with the bias hidden. And once this computation has been done, this has been forwarded to the activation function. So here the activation function is a sigmoidal function. So this sigmoidal function calls out to this function and executed this 1 divided by 1 plus np dot exponential value of minus x. This has been computed and has been returned as its result. So we have been done the computation to the hidden layer. Similarly, we are just going to have the computation to be done for the output layer. Once this has been done, we can able to identify the error. So error in terms of the actual values where we have been generated a random value to the set of document, identifying the error, finding out the difference between the actual and the predicted value. Okay. So this error can able to be passed as to the backward propagation. So when you're using this, we are just going to have the backward propagation to be computed so that we are just going to have the minimized error to be obtained. Okay, so the computer error will be multiplied with the sigmoid derivative in its output layer. So sigmoid derivative is the function where we have been defined earlier. So this function will be activated, process it to the input weight. Okay, now similarly with the hidden layer, we are just going to have the sigmoidal derivative of it, obtain the gradient to the output as well as the hidden have been done. Once you have been obtained the gradient for the output as well as the hidden, we are just going to update the weights. So updating the weights in terms of the previous value. Okay, you are going to update the weights regarding to the hidden layer. So this, and regarding to the bias also you are going to update it. So we are just going to have the same set of information to be retained as such. So keep dimensions is going to be true, maintaining as such. When you're going to have this computation to be done, we are going to multiply it in terms of the learning rate. So learning rate where we have been identified as 0.5 to be mentioned out. So this is our neural model. So here we have been represented each and every document, assigning the weights as well as the input feature, the word, with the bias. We are just going to have a computation of a function, then finding out this activation function for it, apply the activation function for it, then determine the error. Once you have been determined the error, then identify the gradient of it for your weight as well as the bias. On identifying the gradient of weight as well as the bias, update or adjust the weights as well as the bias in terms of the learning rate. So this is our basic perspective of your neural model. Once this has been done, you can able to go in for the other perspective of query, retrieving the documents. Given a query, how you can able to retrieve it. So you are going to have a definition for your retrieved documents, stating that you are going to pass the query and you are just going to reflect back the top 5 results of it for that particular query. So given a query, you are going to have a vectorizer to be deployed for that query. Here the vector is going to be the TF-IDF vectorizer form. Okay. The query has been transformed. Okay. So this query vector will be used for the similarity measure. Here we have been used the cosine similarity measure to be taken up with the query as well as the document. So this vectorizer will be a matrix representation. So we are flattening out, so a single dimension, where the relevancy score will be stored for that particular query. Okay, so we are going to identify the top 5 results to be there. So relevancy score, we are going to sort it out and return the top 5 elements from that relevant, from the associated document feature. So we are going to identify the set of documents. So from the index in top indices, so here we have been identified and listed out as a top indices. For those indices, we are just going to reflect the relevancy score as well as the corresponding document name. Okay. And this has been returned to the retrieval of documents. So this is just the definition for the document, retrieved document. We are going to give a query, assign a query, and for this query, we are just going to identify which document is similar and identify 5 documents and end it to the end results. Okay, on running this, we have in this folder we have 10 documents. Out of 10 documents, the first example 1.txt, which has the information retrieval, and D9 has the relevancy score of 0.37, and the other documents have been related to the word of information retrieval. Now we can able to change it in terms of IR, whether any of the documents has been related to IR. The short form of information retrieval can able to be check it out. Yes, the first document itself which holds the IR. So it is going to be similar to the word which has been associated to the particular feature. Okay. So here the feature which has been represented in terms of the documents, each document has been associated to weights, and based on the weights, we are just going to retrieve it back. So what are the steps to be followed to have your implementation of neural network model is, first you are supposed to load and preprocess the data, then convert the text into numerical representation. Here we have been converted into your TF-IDF vectorizer. Then we are going to have an initializing the neural network model in terms of your input layer, hidden layer, output layer, weights and bias. Then we are going to train the neural network in terms of your backpropagation, so that you are going to have a set of training parameters. You are going to set a training parameters, the learning rate as well as the epochs, generate the random labels to identify the error and to compute the gradient and update the weights. So this will be carried out as a backpropagation aspect. So initially we are just going to have a random labels to be generated and compute the forward propagation. Okay. I'm going to compute the forward propagation in terms of your activations for your hidden as well as your output layers, and apply the activation sigmoidal activation function and compute the error. So this is the task which have been assigned for your forward propagation. Then During the backward propagation, you are going to compute the gradients using your sigmoid derivative and assign the weights and adjust the weights and bias using your gradient descent. So this is your entire model setup. Okay, you have been converted your set of documents to a neural network perspective. Once this has been done, you can able to check it out with your query that have been given. So retrieving the relevant documents for those tasks, we are going to have a query to be converted into a TF-IDF vector, compute this cosine similarity measure, and sort it out based on the relevancy. Return the top document to it. So you can able to have your neural network to be applied in a retrieval process so that you can able to understand the semantic information from the document, which can able to gain the relevancy to the user query.